Dynamic programming is the process of subtracting mixed problems into recurring subproblems, solving each problem only once and remembering it, and using it to solve a larger problem whenever necessary. That is, the basic logic is that if there are repetitive calculations in a problem, let's solve this part of the problem once and memorize it, and use the calculated answer instead of recalculating it every time. This is called memoization. Dynamic programming takes up a lot of memory because it stores subcalculations, but it saves time instead. Dynamic programming can be used for all problems that can be broken down into smaller pieces. Here are some problems that can be solved in optimal time with the help of dynamic programming. 1. Knapsack problem. 2. Levenshtein distance. 3. Matrix chain multiplication. 4. Assembly line scheduling. 5. Dijkstra. 6. Fibonacci. 7. Rod cutting problem. Dynamic programming consists of three main steps. 1. Determining the structure of the optimal solution. 2. Recursive writing of this optimal solution and calculation of subproblems that can be calculated. 3. Calculate this optimal solution with the help of calculated subproblems. In this case, the bottom-up method is used. Top-down is used in more iterative calculations. For a better understanding, let's look at the solution of Fibonacci numbers with dynamic programming. We know that Fibonacci numbers are calculated as follows. 1, 2, 3, 5, 8, 13, 21, 34, 55. That is, fib n equals fib n1 plus fib n2. Recursively, we can solve Fibonacci numbers in this way. If n less than equals 1, return n. Else return f n1 plus f n2. If you write a recursive Fibonacci calculation and debut with different numbers, you will see that. 1. It works slowly as the numbers increase. 2. Repeat the same operation each time. That is, suppose we calculate fib 8. In this case, 1 times fib 7, 2 times fib 6, 3 times fib 5 will be calculated, and 8n times fib n will be calculated. As you can see, this calculation is not an optimal calculation. What can we do to prevent this? I think the first thing that comes to mind is to take those calculated values from memory and use them when needed. Yes, that's what dynamic programming is all about. Now try to write the Fibonacci method to apply it with dynamic programming. First, we created an array to store the calculated data. Then each time we calculate the answer using the previously stored data memoization. Thus, we have minimized the number of calculations. But we used a lot of memory. We can also optimize memory. Let's try to do that. In this article, we have made a simple introduction to dynamic programming. In the following articles, we will look at solving more complex problems with dynamic programming.